Okay. So I can use the digital whiteboard.
Oh.
So the reason I'm using Zoom and using the digital whiteboard is because this lesson is the lesson that 10A need tomorrow. So I'm going to record it and just make them watch it. So, hi 10A, you're getting a recycled 10B lesson because they're my favorites. No, and I'm going to cut this bit off. Okay. Yeah. Okay. Okay. All right. So we are going to look at differentiation today. So thankfully, no more graph drawing, which is nice. So what we're going to learn is how to differentiate an equation. You don't really have to do much with this, but you do need to know what it means. It's a lot simpler than it sounds. There is a very simple rule and it's always the same. So differentiation is how to find the gradient of curved lines. So we've talked about that before. Again, it doesn't matter. Like you don't need to really understand it. Okay, that's the terrible approximation way, right? You draw a tangent at the curve and then find the gradient of the tangent. That is a way you can do it. But we're going to learn how to do it algebraically, so you don't have to draw graphs. Surely that's better, right? No more graph drawing. I promise it's not actually that bad. So let's say that I have y equals x squared. What I'm going to do, so the way we write differentiation is dy dx, okay? It's just the way we do it. This means the differentiation of y and x, okay? That's what's going on here, so don't worry too much about it. All I do is bring the power down in front of the letter and then subtract it by 1. How easy was that? Let's do another one. Y equals x cubed. To find dy dx, so you bring the power down in front of it and it's squared because I subtract 1 from it.
Oh, that kind of subtraction.
Don't worry, it doesn't matter. Like honestly, this is what you do next year. You learn all about why it works and all of that sort of stuff. For now, we don't care. We're just following the rule. Same thing. Watch this. Y equals x to the power of 4. Dy dx 4x cubed.
Oh.
Right, so the number comes down and this gets reduced by 1. Equals x to the power of 5. 5x to the power of 4. Just so you can see it.
But then,
I'm going to, okay, we've got to add stuff to it. Yeah. Same thing. Bring it down and multiply. So I don't think we're doing any negatives though. So don't worry too much about that. Yeah, it's the same rule. So what we're going to do now is look at what would happen if there was actually a number in front of it already. Okay, but it's the same idea. So what if, that's exactly right. What if I had 3x to the power of 5? So the dy dx, I bring down the 5 and then I multiply it by whatever is already there. So it's 5 times 3, and then I still reduce this by 1. Okay, so if there's already a number there, just multiply it by whatever's there. Really, this is like 2 times 1, right? Which is why it's 2. 3 times 1, which is why it's 3. That's what's happening, right? Okay, so if I have, if I have y equals 6x cubed, what's the differentiation of it?
18.
Good. 18x squared, because 3 times 6 is 18, and then I just reduce it by 1. See how easy it is? There's not a lot to it, right? It's the same rule over and over and over again. The same is true even if this is negative. So if I say y equals negative 3x to the power of 6, well, actually I've already done a 6 and a 3, haven't I? Let's do 4. What happens? Yeah, that's what C1 just said. We're not dealing with any of those, but it's the same thing.
Cube, x cubed.
Right. Negative 12x cubed dy dx. Okay. So again, the differentiation, you just bring it down, multiply it by whatever's there and reduce it by 1. Okay, so then what if they ask us to find the gradient at a point? Why is it always going to be at a point? Why can't I just find the gradient once I've differentiated? because it's mostly still a curved graph. If it's a linear equation, so if I said y equals x squared, then dy dx is what?
X1. Oh, 2x.
2x.
Okay, 2x to the power of 1, right? So it's just 2x. What is the gradient of this line? 2, right? Because y equals mx plus c, right? That's a general linear equation. This is m, right? Because it's in front of x. So that is the only time you can just read it. Apart from that, we're finding the gradient at a curve, at a point. Because in a curvy graph, if I draw a curvy graph, the gradient is always changing. What does the gradient measure? The steepness of a line, and the steepness is always changing. So I can only ever measure the gradient at a point. I can't ever measure a general gradient of a curved line. So let's do an example where we do that. Okay, so y equals, let's say, 4x cubed. Oh, look at this. I'm going to make life harder. Okay. Nah, it's the same thing. You just do two things at once. So what's the gradient of this? 12x squared plus 4x, right? So I bring this down, which is 12, subtract 1. Bring this down, which is 4, subtract 1. Now, if I want to find the gradient at the point, let's say 3, 1. I want to find the gradient when this is a point. So what would I do? Plug what in? Just x, right? Because this is xy. So all I care about is putting x into this formula. Okay, so the gradient at this point is 12 times 3 squared plus 4 times 3. So we've got 12 times 9 plus 12, which gives us what? What's 12 times 9? Wait, what?
118. Oh my God.
120.
Okay, so this is obviously a very steep gradient. Yeah. So what this means is that this is going to be an extremely steep line at this point. That's fine. Generally speaking, we're only doing one thing at this point, I think. So let's do another example. So y equals negative 3 to the power of 3x to the power of 5. So what's dy dx? Good. Okay, so I want to know the gradient at the point negative 2, 4. What would I do?
Stick the next 2 in.
Okay, so negative 2 is the bit that I care about. That's going to be in place of x. So negative 15 times negative 2 to the power of 4. So negative 15 times what?
Negative 16. No, it's going to be positive. 64.
2, 4, 8, 16.
Great.
Right? We're just doing it 4 times. I don't know why. And then we multiply these two numbers. Someone do that for me.
It's 80.
What? That's not possible. What?
I did 5.
Okay, so that is the gradient at this point of this graph. Do we get what I'm doing? Okay. Let's keep looking. It's exactly right. That's right. Okay, so there are a couple of special cases. Not really though. Okay, so if I have y equals 6x minus 3, and I want to find dy dx, what do I do?
5.
X to the power 6.
X to the power negative 1.
Okay, so this disappears. Anytime you've got a constant, you don't do anything because this is 1, right? If there's no number, it's 1. Yeah? So then 1 minus 1 is 0. What's anything to the power of 1? See, we didn't need to do that because we know mx plus c, right? So we know that this is the gradient anyway, but I just did it through differentiation to prove a point, right? So you don't need to differentiate this to know what the slope is because it's a linear equation, but I'm just showing you why it works anyway, because you subtract 1 from this power, which makes it 0. Anything to the power of 0 is 1, and it just ends up being itself anyway. Huh? Yeah. Because when we differentiate, you have to subtract 1 from the power. Well, then it would be 1. So if you had 6x squared, then it would be like 12x, right? Yeah. It doesn't go any, it disappears because it has no variable. So we can't differentiate it. So if you have a number by itself, you just ignore it when you're differentiating. So let's do an example where that's true. Good question. So 3 plus 5x squared plus 7. Okay, so let's differentiate this. We're going to do all the terms separately. Let's just pretend they're 3 separate equations. What's the first one?
12x cubed.
12x cubed. What's the second one? 10x. And this one just doesn't exist anymore, right? It's got no variable, so we can't differentiate it. So this is the differentiation of that.
So if it doesn't have an x.
Just ignore it. Yep, you cannot do anything with it. Okay, the other, so this is all pretty simple, right? It's all pretty straightforward. Once you know the rule, it's the same thing over and over again. The only time it might become slightly tricky is when you have to combine this with other knowledge that we have. So let's do an example of something. What if I said, okay, if I asked for the differentiation of this,
2x.
what? Span first.
Plus. What?
What does it mean when I have a squared like this? It means there's 2 of them.
Minus plus 4 and minus 1. Wait, what?
Minus 14. Same thing.
Okay, remember, oh, no, that's an equal sign. I'm just really bad at drawing. Okay, remember FOIL, first outside, inside, last. And then as people were saying before, this is minus 8x because these two things belong together. Plus 16. Now I can differentiate. Now it is a single term. Well, it's sorry, and now it's all expanded, right? Now I can find dy dx, which is 2x minus 8, which is just 8, right? Because remember, this is 1. This is just what we were doing before. So 1 minus 1 is 0. So this bit is just 1, right? So that is the differentiation of that.
Wait.
If you have something like that, expand it first.
Okay.
How did that?
How did which?
The minus 8.
That's this bit.
How?
Minus 4.
Because 1 minus 1 is 0. So that's why anything to the power of 0 is 1, right? This is 8x,
The power of anything.
which becomes 8x0, which is 8 times 1, which is 8.
If you choose the power of 0.
Anything to the power of 0 is 1, right? That is what happened to this thing, which becomes this thing.
Okay.
Okay, let's do one more example of that. Okay, y equals 3x plus 2 squared. All right, so what do I do first? Yeah, let's do FOIL. Exactly, write it out twice. Yep, so 9x squared. Let's not do it all at once. Let's try and do it in the actual steps. So then the outside, right, plus 6x, plus 6x, plus 4. You're right that you can shortcut it, but not everyone can. So I just want to show the process. All right, now let's find dy dx. What do I get? 18x plus 12. That's it. That is the gradient of this. Don't think there's anything else. I think that's it. Okay, you will notice on your timetable, we're skipping a couple of exercises. We're skipping 8.10.
Oh, yeah, we are.
And we're jumping straight to 11, 12, 13. All right. It's all differentiation. It's all the same. There's no graph drawing. This is what we're doing. Right. I am going to stop the recording. So 10A. 10A. You've got exercises 18.11, 12, and 13 to do today because we're skipping 10. Hopefully you picked that up. Good luck. Please drop me an email if you need some help. But I may not answer you because I'll be in conferences. All right. Bye.